Welcome in the third lecture of the series of a sequence. So, in the last lecture, we study here the what is the bounded above sequence and a bounded below sequence, okay, and the convergence of the sequence. So there is a theorem. So what is the theorem? An increasing sequence which is bounded above is convergent. Okay? An increasing sequence which is bounded above is convergent. म्हणजे बाउंडेड अबाव सिक्वेन्स ही कॉन्व्हर्जंट असते हे दाखवा म्हणलेलं आहे. तत्पूर्वी सुरुवातीला आपण एक एक्झाम्पल घेऊ. सो दॅट इज अन इम्पॉर्टंट लिमिट. Limit as n tends to infinity 1 plus 1 upon n rest to n is equal to e. So this is the important limit. So limit of this is e. So we prove this example here and then prove the theorem an increasing sequence which is bounded above is convergent. Okay. Proof. Let Sn, nth term of this sequence is, so that is Sn is equal to 1 plus 1 upon n rest to n. Then by binomial theorem. So what is the binomial theorem? So a plus b rest to n is equal to nc0 a rest to n plus nc1 a rest to n minus 1 b and so on ncn b rest to n. Okay, so this is the binomial theorem here. Okay, now so we obtain the binomial theorem for this. Binomial theorem for 1 plus 1 upon n raised to n, where a is 1 and b is 1 upon n. Then we expand this by using binomial theorem. Okay, so what is nc0? nc0 is 1. Okay, what is a? A is 1. 1 raised to n is 1. So, okay, and b raised to 0. So, 1 upon n raised to 0. So, that is 1. So, this is the first term. So, what is the second term? nc1. nc1 is n. Okay, a is what here? 1. 1 raised to n minus 1 is 1. And b is what? 1 upon n. So that this is as it is, and so on. So this is the expansion of 1 plus 1 upon n raised to n. Okay. So this is the nth term of this sequence. So Sn is equal to. So 1. So n get cancelled. So this is 1. So 1 upon 2 factorial. Then divided by n square to this n get cancelled, dividing by n. So this is 1 minus 1 upon n. Plus similarly 1 upon 3 factorial. 1 upon 3 factorial. Okay. Then dividing by n cube to this term. So n get cancelled, dividing by n to this term, dividing by also n to this term. So we get this term here. Okay. Similarly 1 upon n factorial dividing by n raised to n. So n into n times to this term. So n get cancelled. So n upon this is this, n upon this is this, and so on. Okay, and so on. So here 1 means here n. So last term is n minus 1. So this is last term. So dividing by n, so this is 1, n minus 1 divided by n. So we say that this is equation number 1. So this is Sn. एक आहे Sn. Then now we similarly find here what is Sn plus 1 term. So Sn plus 1 term means putting here n is equal to n plus 1, n is equal to n plus 1, n is equal to n plus 1, and so on. So we get Sn plus 1. and we say this is equation number 2. Okay, so this is Sn, so this is Sn plus 1. Okay, so we compare this Sn and Sn plus 1 by comparing Sn and Sn plus 1. So see here, so what is this? 1 minus k upon n is less than 1 minus k upon n plus 1 for all k is equal to 1, 2 and so on. Okay, for example, k is equal to 1, 1 minus 1 upon n, so this is 1 minus 1 upon n. Put k is equal to 1, 1 minus 1 upon n plus 1, so this is, and this is always, हे नेहमीच येतं, काय प्रश्नच नाहीये. त्यामुळे ही टर्म ह्याच्यापेक्षा लहान असणार आहे, ही टर्म ह्याच्यापेक्षा लहान, ही टर्म ह्याच्यापेक्षा लहान, and so on. So we directly say that. So we directly say that Sn, so Sn less than Sn plus 1, Sn plus 1. So for all k equal to 1, 2 n. इथं मी आता बघितलेलंच आहे. So ही टर्म ह्याच्यापेक्षा लहान, ही टर्म ह्याच्यापेक्षा लहान, ही टर्म ह्याच्यापेक्षा लहान, म्हणजेच Sn is less than Sn plus 1. Okay. So if Sn is less than Sn plus 1, therefore the sequence Sn is said to be monotonic increasing. म्हणजे ही सिक्वेन्स कशी आहे? increasing sequence आहे. Okay, increasing sequence आहे. So from equation 1, okay, so this is Sn here, Sn, okay, from equation 1, so Sn is what here? Sn is this. So Sn is this. So 1 as it is, this 1 as it is. So 1 minus n, 1 minus 1 upon n. So this is always, less than 1. Less than, this is always less than 1. Less than 1. So therefore this is less than 1. This is less than 1. This is less than 1. So therefore Sn is less than 1 plus 1. So this is less than 1. So this is 1 upon 2 factorial. So this is less than 1. So this is 1 upon 3 factorial and so on. So we get Sn less than 1 plus 1 plus 1 upon 2 factorial plus 1 upon 3 factorial plus 1 upon n factorial. Okay. So this can be written as 1 as it is, 1 as it is. So 2 factorial is 1 into 2, 3 factorial is 1 into 2 into 3, and 1 upon n factorial is 1 into 2 into 3 into n. Okay. So this is less than, so this is less than 1 as it is, then 1 as it is, so 1/2 as it is. But 1 upon 2 into 3 is less than 1 upon 2 into 2. 1 upon 2 into 2, म्हणजे 1 upon 6 is less than 1 upon 4. So that is 1 upon 2 square. 1 upon 2 square. So this is less than 1 upon 2 square. Similarly, this is less than 1 upon 2 raised to n. Okay. So this is the geometric series. So 1 plus 1/2 plus 1 by 2 square plus 1 upon 2 raised to n. So this is a geometric series with the common ratio. R is equal to 1/2. R is equal to 1/2. Common ratio means 1 upon 2 square divided by 1/2. So this term divided by this. So this is 1/2. And this is same throughout. Okay. First term is 1. So what is the sum of this series? So this is what is the sum of this series? So that is the partial sum of n terms here. So what is the sum of the series? So 1 minus 1/2 common ratio raised to n divided by 1 minus r. That is 1 minus 1/2. Okay. So this is 1 minus 1 by 2 raised to n divided by 1 minus 1 half is 1 half. So 2 comes here. So 1 plus 1 minus 1 upon 2 raised to n. So Sn is less than this. Sn is less than this. Therefore, Sn is less than 3. Why? So find out this limit of this. Limit of this is 1 minus 1 upon 2 raised to n is 1. And 2 raised to n, so as n tends to infinity, this tends to infinity. So 1 upon this tends to 0. So limit of this is 1. So limit of this is 1. So 1 plus 2 is 3. So Sn is less than 3. मग आता इथं काय आलं सांगा भाऊ. So the Sn is less than 3. So 3 is upper bound. Hence the sequence Sn is bounded above by definition. म्हणजे सिक्वेन्स कशी आहे, बाउंडेड अबाव सिक्वेन्स आहे. आता ह्यापूर्वी आपण शिकलेलोच आहोत. हे बघा इथं काय झालं, इथं द गिवन सिक्वेन्स Sn is monotonic increasing. Given sequence Sn is monotonic increasing. So that is proving. That is proving. Also here the sequence Sn is bounded above. The sequence is bounded above. Then by theorem, काय सांगतो theorem? An increasing sequence which is bounded above is convergent. So this sequence is increasing as well as bounded above. Then by theorem, the given sequence is convergent. The given sequence is convergent. Okay? So by theorem here. So we find the limit. Limit as n tends to infinity. 1 plus 1 upon n is equal to e. हे लिमिट आपल्याला काढावं लागेल. ओके, ठीक आहे. So from equation 1. Okay, from equation 1. Here 1 plus 1 upon n. 1 plus 1 upon n raised to n is always greater than 2. Is always greater than 2. Because 1 plus 1 upon n raised to n is always greater than 2, because each term of Sn is positive. So 1 plus 1 is 2 here. 1 plus 1 is 2 here. And this is addition term. So this is greater than 2. And you say that Sn, limit of this is less than 3. So the limit of this is lies between 2 and 3. आणि आपल्याला माहितीच आहे ई ची किंमत 2 आणि 3 च्या मध्ये असते, म्हणून याचं लिमिट ई असतं. ई इज ऑलवेज लाइज बिटवीन 2 and 3. इज अ ट्रान्सडेंटल नंबर. ओके, सो लिमिट ऑफ 1 plus 1 upon n raised to n as n tends to infinity is e. So we prove here the important limit. So limit as n tends to infinity, 1 plus 1 upon n raised to n is equal to e. So that is the example. By prove here this example by using this theorem. Okay. So now we prove. Now we prove actually this theorem here. We prove theorem. Okay, we prove this theorem. Suppose sequence Sn is an increasing and bounded sequence. Suppose sequence Sn is an increasing and bounded sequence. So now we prove that that sequence is convergent. जर ती sequence increasing and bounded above असेल sequence, then we shall prove that here the sequence is convergent. Then A is equal to, we take a set. So that is S1, S2, S3 and so on. Is non-empty subset. Subset of R. Is a non-empty subset of R and is bounded above. असा एक सेट घेतला आपण. So we take here A is a set. A is a set of S1, S2, S3. So we take here the elements from that sequence, and we say that this set is A, and this is a non-empty subset of real numbers, and which is bounded above. Okay, therefore A has least upper bound. A has a least upper bound. Therefore A has least upper bound. That is, let म्हणजे ह्या सेटला लिस्ट अपर बाउंड आहे. लेट m इज इक्वल टू LUB, त्याला त्या अपर बाउंडला आपण काय म्हणू शकतो. सो दॅट इज m, so that is S1, S2, S3 and so on. S1, S2, S3 and so on. So what is upper bound? So we know what is upper bound. So for example, say yes, n 1 upon n is a sequence. So this is 1, 1/2, 1/3 and so on. So this is a sequence. Okay. So what is the upper bound here? So m is 1. For example, m is 1. So this is upper bound, and each term, this is a set. We take a set, and each element is less than 1. Each element of the set is less than 1. So this is the upper bound. Okay. मग आपण लिस्ट अपर बाउंड कशाला म्हणतो? थोडक्यात मी रिव्हिजन करतो लिस्ट अपर बाउंडची. तर लिस्ट अपर बाउंड कशाला म्हणतो आपण? कारण का all those elements are less than equal to m. Okay, so that is 1. So all elements are less than equal to m here. M is equal to 1 here. So what is this? Is m is upper bound. So what is a list? आता लिस्ट म्हणजे काय हा प्रश्न आहे. तर आता हे जे एलिमेंट्स आहेत ते 1 पेक्षा लहान आहेत. याचा अर्थ ते 2 पेक्षा लहान आहे. याचा अर्थ ते 100 पेक्षा लहान आहे. 100 पेक्षा लहान आहेत. म्हणजे हाही अप्पर बाउंड, 2 इज ऑल्सो अप्पर बाउंड, 100 इज ऑल्सो अप्पर बाउंड. परंतु हे आपल्याला काय संबंधच नाहीये. याचा काही संबंधच नाहीये. त्यामुळे वी टेक लिस्ट ऑफ दोज. So that is 1. So 1. So this is the list upper bound here. List upper bound. So we remember here the definition of list upper bound. So for given epsilon positive, however small, for given epsilon positive, so m minus epsilon is not list upper bound. List upper is not LUB, list upper bound. जर तुमचा m हा अप्पर लिस्ट अप्पर बाउंड असेल आणि त्यातून तुम्ही जर मायनस सबस्ट्रॅक्ट केलं तर तो लिस्ट अप्पर बाउंड राहणार नाही. म्हणजे मगाशी 1च्या तिकडे जाईल कुठेतरी. ओके, 0.9 वगैरे समथिंग, 0.99999. त्यामुळे त्याला आपण लिस्ट अप्पर बाउंड म्हणू शकत नाही. Therefore m minus epsilon is not list upper bound for set A. For A. For set A. Okay? Okay. Therefore, Sn is greater than n minus epsilon. m minus epsilon. आता हा लिस्ट अपर बाउंड राहिलाच नाही, त्यामुळं सगळे एलिमेंट याच्यापेक्षा कदाचित मोठे असतील. फॉर सम आफ्टर एन, फॉर सम एन. ओके, फॉर सम एन, just a minute, it belongs to I here. It belongs to I. But sequence Sn is an increasing sequence. But sequence Sn is an increasing sequence. Therefore, this implies that Sn greater than m minus epsilon, where n greater than en. Okay, after en, capital N, Sn is greater than m minus epsilon. Okay, so by using this we write here. Okay, by using this we write here. So this is equation number 1 here. Equation number 1. On the other hand, since capital M is list upper bound. Capital M is list upper bound for A. Therefore, Sn is less than equal to capital M. Okay. जर m हा लिस्ट अपर बाउंड असेल, then by definition Sn is less than equal to m. So this implies that if Sn is less than m, then automatically this is Sn is less than m plus epsilon. So equation number 2 here. Okay, equation number 2. So from 1 and 2, what happened? From 1 and 2, so Sn is greater than m minus epsilon and Sn is less than m plus epsilon. So we get here m minus epsilon less than Sn, m minus epsilon less than, so that is less than m plus epsilon. So we say that if this is m minus epsilon is less than Sn, less than m plus epsilon, so therefore mod of Sn minus m is less than epsilon. For n is greater than equal to capital N. N is greater than equal to capital N. So this inequality we convert here. हे तुम्हाला माहिती आहे, कारण का जर इथं काय असतं बघा, Sn minus m is less than epsilon. Sn minus 1 is less than epsilon, and mod having two values here, minus Sn minus m less than epsilon. So what is this? Minus Sn plus m less than epsilon. Okay. So what happened here? Sn इथं गेलं. So m minus epsilon is less than Sn. Okay. So this is this. आणि हे अगोदर माहितीच आहे. त्यामुळं हे असं लिहू शकतो. आणि दिस इज अ डेफिनेशन ऑफ लिमिट ऑफ सिक्वेन्स. देअरफॉर लिमिट ऑफ Sn as n tends to infinity is equal to m. Is equal to m. Therefore, the sequence Sn having limit m. Hence, the sequence Sn is a convergent sequence. We take here sequence is increasing and bounded above sequence and prove that this sequence is convergent sequence. Hence the theorem. So an increasing sequence which is bounded above is convergent. So the proof is completed. Okay. Proof is completed. So what is the next theorem? Similarly, next theorem is what here? See the theorem. And a decreasing sequence. Decreasing sequence. Decreasing means what? Non-increasing. Decreasing sequence which is bounded below. Is convergent. म्हणजे एखादी सिक्वेन्स डिक्रीजिंग असेल and ती सिक्वेन्स बाउंडेड बिलो असेल, then that sequence is convergent. So what happened here? What is the sequence? So Sn is a sequence. Okay, sequence. So what is the decreasing sequence? Decreasing sequence, you know definition. So Sn greater than equal to Sn plus 1 for all n is equal to 1, 2, 3, 4. So this is the definition of the decreasing sequence here. So Sn is greater than equal to Sn plus 1. And if the sequence Sn is bounded below, means Sn bounded below means what? Sn is greater than equal to something small m. So m is a lower bound, then the sequence is bounded below. For all n, bounded below. So increasing. Sequence. So the sequence is increasing and bounded below, then the sequence is convergent. जसं मी पहिला थेरम प्रूव्ह केला तसाच तुम्ही ह्या पद्धतीनं तो थेरम प्रूव्ह करा. इथं रिपीट करण्याची काहीही गरज नाही आहे. ओके, तर या ठिकाणी आपण एक थेरम घेतला आणि एक इम्पॉर्टंट लिमिट घेतलेला आहे. ओके, तर याच्यावर फार सिंपल एक्झाम्पल्स मी उद्यापासून घेणार आहे. तर एक्झाम्पल्स आणि प्रत्येक टाईपचं एक एक्झाम्पल या ठिकाणी मी डिस्कस करणार आहे आणि होमवर्कसाठी तुम्हाला एक्झाम्पल ठेवणार आहे, तर ते तुम्ही सोडवायचे आहेत. तर या ठिकाणी सिक्वेन्स, व्हॉट इज increasing sequence and what is the bounded sequence तुम्ही शिकलेला theorem झाला. and increasing sequence which is bounded below, then it is convergent, and second theorem, and we learn here what is the important limit of 1 plus 1 upon n raised to n is equal to e. so हे काढलेलं आहे, त्याच्यावरून आपण काही एक्झाम्पल उद्या ह्याच टाईपची घेणार आहोत. तर तत्पूर्वी तुम्ही ह्या जो म्हणजे युट्यूबवरती जे व्हिडिओ आहे त्याला सबस्क्राईब करत जा, म्हणजे तुम्हाला सगळी सिक्वेन्सची सिरीज मिळेल. ठीक आहे, धन्यवाद.